The year is 1900, off the coast of Antikythera, a tiny, wind-battered Greek island that barely shows up on most maps. A group of sponge divers are forced to take shelter from a storm. To pass the time, they do what sponge divers do. They dive. 60 meters below the surface, they find a shipwreck, ancient, Roman era, and absolutely loaded with treasure. Bronze statues, marble sculptures, gold jewelry, glassware so delicate it had somehow survived 2,000 years beneath the sea. This was one of the greatest archaeological discoveries in history, but none of that is what this video is about. Because tucked among all that gold and marble, divers pulled up something else, something nobody knew what to do with. A green calcified lump, roughly the size of a shoebox, crusty with corrosion crumbling at the edges. It looked like a rock that had eaten another rock. Archaeologists cataloged it, boxed it up, and set it on a shelf at the National Museum of Athens, where it sat, ignored, for 50 years. Then, in 1951, a British historian named Derek de Solla Price decided to take a closer look. And in 1971, he convinced researchers to put the lump through X-ray imaging. What they saw inside broke their understanding of history. Gears, dozens of them, precision cut, interlocking, bronze. Inside that corroded lump was a machine, a complex, sophisticated, impossibly advanced machine, and it was 2,000 years old. Here's why this is so deeply unsettling. Before the Antikythera Mechanism was discovered, historians had a very clean, very confident timeline of human technology. Complex gearwork, the kind involving multiple interlocking cogs working together to perform calculations. That didn't exist until the 14th century, medieval Europe. Clock towers, church bells on a schedule. That was the story. The Antikythera Mechanism was built somewhere around 150 to 100 BC. That's not slightly ahead of its time. That's not, oh, they were a bit more advanced than we thought. That is 1,000 years ahead of anything historians believed was possible. The device is small enough to hold in two hands. It has at least 30 individual bronze gears, and researchers believe the complete, undamaged version may have had over 70. The teeth on those gears are cut with a precision that, frankly, shouldn't have been achievable with ancient hand tools. And yet, here it is, sitting in a museum, daring you to explain it. The ancient Greeks didn't just build the Parthenon and call it a day. They were apparently also out here engineering devices that we wouldn't rediscover for over a millennium. So what did it actually do? Short answer, everything. Long answer, let's talk about that. The Antikythera Mechanism was, at its core, an astronomical calculator. You turned a hand crank on the side. One full turn equaled 1 day. And the machine would track the movements of the cosmos with staggering accuracy. On the front of the device, a large dial displayed the position of the sun and moon against the Greek zodiac calendar. You could look at it on any given day and know exactly where those celestial bodies were in the sky. But that's almost the simple part. Here's where it gets genuinely mind-bending. The moon doesn't orbit Earth in a perfect circle. Its path is elliptical, which means it speeds up when it's closer to Earth and slows down when it's farther away. This is called the lunar anomaly, and it makes predicting the moon's position extremely difficult. Ancient astronomers knew the moon moved irregularly, but calculating it, that requires real mathematical sophistication. The Antikythera Mechanism solved this problem using a system of two interlocking gears, one slightly off-center from the other, called an epicyclic gear train. This mechanism physically modeled the moon's irregular orbit. The output of those gears moved a pointer on the display that tracked the moon's actual position in the sky in 150 BC with bronze. But there's more. On the back of the device were two large spiral dials. The top one tracked a 235-month cycle, known as the Metonic cycle, which allowed the mechanism to predict solar and lunar eclipses. Not just that one was coming, but what kind of eclipse, and roughly how large it would appear. A small rectangular window on this dial even included color-coded annotations describing the nature of predicted eclipses. Ancient engineers were essentially building drop-down menus. And then, almost as if to show off, the bottom spiral dial tracked a 4-year cycle called the Olympiad cycle. It literally told you which year the Olympic Games would be held, along with the Pythian, Nemean, and Isthmian Games. This device was a calendar, an eclipse predictor, a lunar tracker, an astronomical clock, a sports schedule, all in a box the size of a hardback novel.
So who built this thing? We don't know. The ship that carried it sank around 60 BC, but the mechanism itself is estimated to have been built 50 to 100 years before that, which places its creation somewhere around 150 to 100 BC in the Greek-speaking Mediterranean world. One name comes up again and again: Archimedes.
Archimedes of Syracuse is often called the greatest mathematician of antiquity. He calculated pi. He invented methods that foreshadowed calculus by nearly 2,000 years. Ancient writers, including Cicero himself, described Archimedes building mechanical models that simulated the motion of the sun, moon, and planets. Archimedes died in 212 BC, a little earlier than the mechanism's estimated date, but it's entirely plausible that the device was built by one of his students, or by engineers working from his principles. Because here's what's remarkable about the math inside this machine. It's not purely Greek. Researchers have identified elements of Babylonian arithmetic embedded in the gear ratios, specifically in how the mechanism models the moon's irregular motion. The Babylonians had spent centuries recording astronomical data. The Greeks had geometry. Someone, some extraordinary mind, fused these two traditions into physical form, into metal and motion. The gear ratio used to model the lunar anomaly, 254 rotations of one gear for every 19 of another, encodes a mathematical relationship so precise that modern astronomers still use the underlying formula. These weren't just engineers. They were synthesizers of the ancient world's greatest knowledge traditions. And now we arrive at the part of this story that should genuinely haunt you. If humans could build this in 150 BC, why did it take until the 14th century AD to build anything remotely like it again? That's a gap of 1,500 years. Think about what that means. The knowledge existed. The mathematical foundations were there. The metalworking techniques were clearly capable. Someone did this. It wasn't theoretical. It was built, it was used, it worked. And then it vanished. Not gradually, almost completely.
The Library of Alexandria, the ancient world's greatest repository of knowledge, was damaged and eventually destroyed across a series of events spanning centuries. We'll never know exactly what was lost, but whatever texts describe devices like the Antikythera Mechanism, whatever engineering manuals, whatever mathematical treatises went into building it, most of them are gone. The Roman Empire's collapse disrupted the trade networks, the centers of learning, the patronage systems that allowed specialized engineers to exist in the first place. The Byzantine Empire preserved some knowledge. Islamic scholars preserved and expanded more. But the specific intricate tradition of Greek astronomical engineering, it broke.
Historians sometimes call this a dark age of technology, and the Antikythera Mechanism is the most heartbreaking proof of it. Because this wasn't lost knowledge in the abstract. This was a physical object. We can hold it, we can scan it, we can reconstruct it. And when we do, it works perfectly. The gears still encode accurate eclipse predictions. The ratios still reflect real lunar mathematics. 14 centuries of civilizational disruption couldn't change the fact that this machine was right. What changed was our ability to make it.
There's a word for this in the history of science: techne, the Greek word for craft, for art, for the knowledge embedded in doing. You can write down a recipe, but some knowledge only lives in the hands of the person who built it and dies with them. The Antikythera Mechanism may be the greatest example in human history of technique that was almost entirely lost. Almost. The Antikythera Mechanism sits today in the National Archaeological Museum in Athens. Fragments, corroded, incomplete, and yet it is arguably the most important single object ever recovered from the ancient world. Not because of what it's made of, not because of where it was found, but because of what it proves. It proves that human beings, long before electricity, long before the printing press, long before calculus was formally invented, were capable of thinking at a level of complexity we never gave them credit for. It proves that the arc of human intelligence doesn't simply go up. It rises and falls and rises again, and entire chapters of genius can be swallowed by the sea. The shipwreck at Antikythera has still not been fully excavated. There are more objects down there, more artifacts, more lumps of corroded, unassuming metal that no one has picked up yet. And it makes you wonder, what other masterpieces are still sitting at the bottom of the ocean, waiting to rewrite history? If this blew your mind, hit the like button. It genuinely helps more people find this video. Subscribe for more ancient mysteries, forgotten science.
Unlocking secrets of the past. This is QSTP for you.